Hey, my name is Richard Sanchez, and I did my project on image noise analysis. The dataset I used is a 400 by 400 matrix of grayscale pixel values, which basically make the image on the right. The noise in the image is the little black and white dots you see all over the picture. The grayscale values are anywhere from 0 to 255, where 0 is black and 255 is white. I chose this dataset because it's unique. You can use a couple different types of ways of getting the noise out, which is those little black and white dots. I thought it would be cool to see a couple different ways of analyzing the image noise. Alright, so here in the MATLAB environment we can call the function noise. I also called the text file noise just to make it easy. And we get an image, this figure, and it says this image has shot noise, which is the black and white specks all over the image, as you can see here. You can use a filter to try to get the noise percentage below 0.5%. So if we use this menu over here, we can see it says plot image noise or plot noise percentage, and it shows that the noise percentage is almost 2.5%. That doesn't sound like a lot of noise, but obviously it's a lot to make it really clear on this figure that there's a lot of noise in that image. We want to get it below 0.5%, which this is showing with this little green box over here, just to give an idea of where you want to get it. Now we can plot the histogram also, which shows that, since we know that 0 is a black pixel and 255 is a white pixel, this noise is all black and white pixels, you can see that there's these big long bars, which shows that there's clearly a lot more black and white pixels than there are any other grayscale value in the entire image. So what we want to do is go over here and say filter noise. And we get this input box which says the original image will now be filtered using a median filter. Please enter an odd number greater than 1. This will determine the size of the filter. So if you enter 3, you'll get a 3 by 3 filter. If you enter 5, you'll get a 5 by 5 filter. But the larger the filter, the more blurry the image will appear after it gets filtered, and this is an effect that's called smoothing. Also, as you choose a larger filter, MATLAB will take longer to do the computation since there's more math involved. So we're just going to go with 3 because that's the value that's already in there. And we'll see that this image over here gets updated, and we'll see that clearly a lot of the noise got filtered out. There's still noise there, but it's almost not even noticeable. So we're going to go back over here. We could say plot noise percentage again, and we can see that that big red box that was over here has gone below the 0.5 mark, and it's now green, which is good, green for good. And we see that it is in the range of the desired image noise. And also, if we look at the histogram, remember how we had these big columns over here for 0 and 255. If we plot the histogram again, we'll see now that these 255 and 0 values have now been reduced. There's still a little bit there, but like I said, it's almost not even noticeable on this image. And so clearly we did a good job filtering that noise. The last thing we can do is plot the negative image. So this image right here, the negative looks like that. And what's interesting about that is you can look at this histogram, and since we know that these are the grayscale values, this is the histogram of the last image before we took the negative of it. And you see this big peak here, and it sort of goes up and then comes down. And if we plot the negative, we expect it to be the opposite histogram, almost a mirror image of the histogram. So if we plot the histogram again, we can see now that this big peak is over here on this side, it comes up and then swoops down, and clearly that is the histogram of the negative image. And we can go back and forth between the original and the negative and replot histograms and filter noise more, whatever we want. If we put a 7 here, let's try that. Like I said, it'll take a little bit longer, but just so you can see, this image here has been filtered with a 3. Now that's with a 7. See, clearly a lot more blurry. And that's it, and then you can exit. And that's all.